Hi, I'm Zachary Trivett and I'm the Library Instructional Technologist at the CLB Library. I'm going to go briefly over the Digital Learning Lab, which is one of the resources available for you to use as faculty to help increase student engagement and success in your courses. The Digital Learning Lab, or DLL for short, is a space for academic and independent active learning. In the education community, this would be referred to as a makerspace. This space, hosted on the second floor of the library, provides access to many emerging physical and digital making technologies. These tools and the materials associated with them are provided at no cost for students, faculty, and staff. Here is a list of the available technologies in the DLL. 3D printing is a technology that melts plastic, called filament, and places it down in layers to build a physical model. Models can either be made in a modeling program or downloaded from a repository. Laser engraving uses a high-powered laser to etch or cut materials based on certain settings. The laser engraver can use various materials such as wood, plastics, cardboard, glass, and more. Our Cricut Maker is a cutting machine that cuts cardstock and sticker vinyl. These cuts can be layered in many creative ways, and there is even an option of cutting heat transfer materials for shirts, bags, and other accessories. We have a video studio equipped with a 4K camera, green screen and lighting, and iMac with editing capabilities. The DLL has a classroom set of Meta Quest 2 VR devices for exploring environments and engaging with various applications. We have 2 robotics platforms, Misty and Sphero, for learning programming algorithms. And finally, our newest addition is our 4-person podcasting studio, complete with mixer, monitoring headphones, and an iMac with editing files for GarageBand. The equipment that requires safety training before use are the 3D printers, laser engraver, and virtual reality, which takes about 30 to 45 minutes. Materials are provided for 3D printing, laser engraving, and the Cricut Maker. Our space runs as a first-come, first-served model and is open from 8 to 5 Monday through Friday. In addition to running the day-to-day of the DLL, I work with faculty to incorporate these technologies into their content. One of the most asked questions is, why should I incorporate this? Makerspaces give your students an opportunity to be creative and engage in hands-on, active learning methods, constructing their own knowledge and understanding. There is a lot of research that states that courses with makerspace activities are more engaging for students. Unstructured activities are not instruction manuals and allow students to find a process that works for them to meet your objectives. Makerspaces afford more opportunities to be collaborative, and users can share information and skills that they have developed over the use of the space. Spaces like the DLL can be environments where students tackle real-world problems, where they learn to create in context. These skills, whether technical or soft skills, can prepare them for future careers. There is also a list of standards called Maker Competencies, which are addressed on our website, that students develop. This addresses skills regarding planning, management of projects, effectively sharing ideas, troubleshooting, and going through the iterative design process. Finally, inclusion of the space is mentioned in our strategic plan priorities. Of course, there are challenges, and I'm here to assist during the entire process. Unfamiliarity with the technology is common. It is not necessary for you to understand the technology, as we teach your students how to use it during a session. Of course, you can set up a consultation to learn more about the capabilities of the technology and also participate in the lesson as it's being taught. Another challenge is more focused on students and that they are interested in producing correct answers. With a space like the DLL, we embrace individuals developing various solutions to the same problem and evaluating them on the process they use to get there. The final challenge is time. Some implementations only require a day, and some might take multiple days depending on the complexity of the assignment. Proper planning with the instructional technologist is key to making sure you can successfully implement these technologies into your course. One of the programs we offer is for first-year seminar courses, and it's teaching a design thinking workshop. We take one class period to give students a quick orientation of the DLL and then teach them about design thinking. which the DLL believes is an essential skill to have inside and outside the classroom. They learn strategies for defining a problem, coming up with potential solutions, prototyping a design with lo-fi materials, and testing it for functionality. The topic can be a real-world problem that we generate or that closely aligns with your FYS content. A lot of our success comes from the free-form projects where the subject matter expert and the instructional technologist work together from the beginning to develop a project that meaningfully incorporates technologies that address objectives of the course. Here are some examples. Students in biochemistry classes explored protein molecules and learned how to use the 3D printer to print them. They then explored these protein molecules in virtual reality and then eventually made a poster presentation on their findings. In general chemistry, students learned about Vesper molecules by accurately modeling them in a 3D modeling software, printing them, and then painting them for accurate representation. A creativity and innovation entrepreneurial course used the DLL for an entire semester learning about all the technologies involved to ultimately make a board game for their final project. This incorporated laser engraving, 3D printing, the video studio, and the podcasting studio. Our exercise science program was tasked with making informational videos about muscles and how to stretch them effectively. These videos are now used on the exercise science YouTube page for the college. A final project for a behavioral neuroscience course was to build a teaching manipulative for the final presentation in class. This is an excellent example of allowing students to choose what technology they want to use to solve this problem for your course. During the beginning stages of the Digital Learning Lab, instructional design students made job aids for how to use some of the technologies within the lab. We have many courses that use virtual reality to experience things that they would not normally have access to. Information systems explored apps that would be used for business applications. Directing watched a 360 version of Hamlet, and a religion course focused in New Testament and Far Eastern religion visited historical sites that were reconstructed in virtual reality. It's great to see students come back to the DLL to do personal projects beyond their first visit with a class. Here are some examples of personal projects that were done, such as 3D printing a face for a Furby, a wedding gift off of the laser engraver, stickers for a club and organization on campus, t-shirts for group travel, and making their own reoccurring personal podcasts. You may have gained some great ideas on how to incorporate the Digital Learning Lab into your course, or you might be overwhelmed with what has just been presented. If you're interested in incorporating the Digital Learning Lab into your course, here are a few things to consider. Do you have a concept that could be better understood with a creative assignment, or something more hands-on that goes beyond the lecture or worksheets? Is there a part of your course where you see student engagement lacking? And finally, do you have any prior data that shows low scores or low participation that might benefit with the inclusion of any of the technologies that are listed? If you are interested in incorporating the Digital Learning Lab into your course in the future, please don't hesitate to contact me. We also have social media that we post on regularly and instructional videos that we post to YouTube about the technology that we have. Thank you, and I look forward to working with you in the future.